All right, everybody, how we doing? Doing good. All right. Today is the final day. This is our 13th video. That's how many videos are promised for this class. That's what I've been doing. If you guys, maybe I should have had this one set up. Enshi. Let's see. Am I still logged in? No. Who loves the push verification? If you have an Apple Watch, you could just press it on your thing. It's pretty cool. Don't have to pull out your phone and. Anyways, let me just log in. I was going to show you Web Campus. Look at all these beautiful classes that I have here. Oh yeah, register now, fall 2026. Don't forget your course evaluations, right? Oh yeah, so I know we haven't been really using this page a lot because Dr. Morris told me, why not just put everything under one thing? And I think I like that. I really do. I'm going to convince Dr. Stuber to do the same thing for next semester. And depending on how you're feeling, Joanna, maybe if you want to grade again for Dr. Stuber, we could do that again. Just let me know. Okay, we'll do the same thing. But yeah, there's a course eval for this class, 360 lecture, and then there's one for 360 discussion, 1003 and 1002 respectively. Okay, so try to fill it out. Let me know. Fun enough, yes, these course evaluations do matter for instructors, for those who are employed here. Tenured, there's a story about that. But anyways, they do matter. So that's my big hint of the day. Okay, everyone listening? So don't do your course evals. I read them. Okay, I really enjoy it. They won't get revealed until after, I think, a week or two after grades are submitted. So there's no what's that thing like where the professor's like, the student graded me badly. Anyways, signals and systems. And then, oh yeah, the video was not recorded for Dr. Morris's class. So for those who came to class, well, you come to class, you paid for it. You got the video or you got the notes, but it's not there. So please come to class. My biggest fear, let me show it. Okay, cool. Is that my video will crash. So I'm hoping it doesn't. It hasn't. So I'm very happy about that. Let me show you pages. And let's show you guys the work you've been doing. Here's my little content. We went through a lot this semester. Gave you guys some notes, videos, right? You guys like the MATLAB code, and then I posted this video a little late, and that's my apologies. It's been a busy week. It's got the PDF. Everyone clicks these PDFs, correct? They're here. What's his name? They may not scan good, but everyone's got these resources. I'm doing this for a reason, to give you guys as much information as we can. How was that direct form 1? Did I do a good job on that? Or by good job, I mean, did you verify my answers? Who finished the assignment for this Friday? None. Who's
But you did make a mistake when you were doing one of, I think it was A1 or A2.
Yeah.
Put it in MATLAB. You just multiply instead of squaring.
Yeah, something like that. Anyways, you see, this is why I love live lectures, where the professor or the teacher, the instructor does things in front of the class, because we make mistakes. Okay, let us know we're not perfect. David's not perfect. Yeah, that's newsflash. Okay. Anyways, that's what Dr. Baker taught me too. He loves live instructions. Funny enough, his joke would be like, "Good, you're paying attention. I make a mistake. That means you know what's going on." He says if he's boring you, that's a good thing, you know, and if you're excited, then yeah, you don't, or I don't know. Anyways, I'm going on a rant. I'm showing this to everyone just in case, because I know there's going to be a complaint, someone saying something didn't happen. Oh yeah, I didn't save the code for the MATLAB online thing, because it was an online thing. It didn't save. That was my fault. So here's the residue of what I left. Were you saying this code, there was an error?
Yeah, go to the top redefine.
Oh.
Yeah, so A2 should have been squared instead of.
Oh. That's where the problem was. That's why I wasn't getting that resonance. Because the resonance should be at, remember how the angle was pi over 4? It should be the pole is at pi over 4. That's the point. So, give you the answers. Verify that my direct form 1 was correct. And I say my because I did it the way I did it, which was, let me show you this. Zoom.
It works.
It worked?
Yeah.
Woo!
You're just changing the current state position. But it's the same.
Wait, where is it? Wait, where's my... Did I click on the wrong box? Is this the wrong one? Give me a second. Oh. Yeah, it looks different. It's not the same one. Where's my direct form? This one right here, right? Okay, clicked on that one. Come on, click. Zoom out. Oh, I guess this... I thought I have 4 rows. Did I give you guys the wrong one? Oh, did I upload the wrong one? Ah, great news. So I guess I don't want to waste time on this. I really don't. But no, this is very important too. January 1st. I don't have it on my thing. I'll upload that later. But that 4x4 square, that's me, okay? I did it A, B, C, D, or I did it all the left side, the X inputs and all the Y outputs. You could have done X1, Y1, X2, Y2, or you can even start from the bottom, Y2, Y1, X2, Y, any way. But the matrix just shifts a little bit, okay? And what if you didn't want to do it the 4x4 way? You could have noticed, I don't want to talk to, I'm going to include this. You're going to see this on your exam, okay? Yes, there is going to be a direct form. Not one. It's a hybrid. He's going to trick you on this exam, okay? Every time you see a memory block, okay? I'm going to put D because I'm lazy. D for David. I don't know. We're dumb here. I don't know. Anyways. B2, B1, B0, okay? Do you guys like how fast I can draw all this? No? Go slower so that we can waste more time on things that we already know. Anyways, D1, because I really don't want to waste time. I want to give you guys your answers. Plus, A1. What am I forgetting right here? I'm forgetting the minuses. Don't forget your minuses, okay? You guys see that right there? Don't forget your minuses. Someone's going to forget on it. Because what does Y and C? It sees these minus things, okay? Because when you have, linear time, not linear time invariant, linear constant coefficient difference equation, right? Those summation functions, the output sees negatives, okay? For the negatives of itself, all right? Everyone knows what's going on. What is this right here again? Direct form 1 block. And what are you going to do on that exam? When he says a direct form state space equation for a direct form 1, you're going to choose. Okay, this is going to be, every state. How did we do it the last time? Did I just say this was X? I'm going to call it QX1 of N, right? And then this one's going to be QX2 of N, correct? You guys like that? And then I'm going to use a different marker, okay? Because I'm learning QX1 of N plus 1, because that's your next state, okay? Okay, if I don't know if he allows different colored pencils on the exam. If you want to, this is how I learn. I'm a visual person, okay? So, and then QX2 right here will be I used the wrong marker. Keep consistent. QX2 N plus 1 over here, okay? And then you can get those state space equations that you need, okay? So if you did it like this, bang, 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 right? That's how I did it the last class, okay? But you guys notice on the for the homework problem that we didn't have a, what was it? Was it an A2 or I think it was a B2 term, right? We didn't have this term for the homework assignment, right? So this is just for a general equation, okay? So we're going to naturally have a 4x4, right? What if you're lazy and you're like, I don't want to do a 4x4. I know B2 is going to equal 0, right? The gain is 0, right? It's an open. Then you don't have to do this. You can just have a 3x3 by having state 1, state 2, state 3. So QX1, and I'm just going to write numbers. Q2 is over here, and then Q3 is over here, okay? Easy stuff like that, and I'm a color person. I love color coding. Q3N plus 1, okay? And then this right here is going to be Q2n plus 1 over here. Any questions about that? So if he's going to get, yes?
I have, I've been using these like translucent sticky notes.
Okay.
Could you use them? I don't know.
Well, I don't know what else he allows. I think he allows, let me see, 3 double-sided pages of handwritten notes as a cheat sheet. Is that what he said?
Yeah.
Okay. And calculators are not allowed. You must show your work in order to get credit for a problem. Correct? So I don't know if he's going to allow that. Is it more like scratch paper?
Yeah, it's kind of like scratch paper. I've been using them for the diagrams to like write over it.
That's actually pretty cool, but I'm not so sure.
Just use a sheet.
Yeah, he'll probably make you say, because he says show your work on the on the exam, because he's not going to have that unless if you think about it, that might be a disadvantage for the rest of your peers who would love to have that. So I guess
You have to buy it off
he just says, well, buy. It's gotta be a resource we have. Anyways, you're given this exam, you gotta roll with it. Okay. Anyways, everyone can do this on the exam, correct? Let me just go over a funny problem. So this is page 1, because let me see, page 1. So let me see. Suppose he gave you the following system, and let me see if I can mimic what he's trying to do. Ooh, this is nice. I like this one. Ooh, yeah, I like this one. Let me see. So he gives you an input. Let me use a black marker. X of n plus. So you see the plus right there, all right? That means you already know what's going to go on, okay? So let's just say he does the following. You see, I'm gonna put a D right there, okay? And then let me just do the following. Yeah, let's just do the following. Okay. How many states do I have? 1, correct? This is the easiest block diagram you can ever draw. You can get your A's, B's, and C's and D's from this, correct? I'm gonna quiz everybody, okay? Q1 of n, correct? That's where I'm going to put it right there, right? And then it's going to be Q1n plus 1, all right? Everyone understanding what I'm trying to do with these color codings, all right? I'm a visual learner, okay? Suppose he did the following to you. He did the following, plus, okay? And now I'm going to do, how am I going to do this? Maybe I should have given myself some more room. I'm going to, okay. I'm going to put a D over here, and then I'm gonna give it a gain of, I don't know, A something, yeah. Minus A, I'll just put an A. Alpha, okay, that's my alpha. I have another D right there. What does that mean? I have another state, so Q2, okay? So that means what's gonna be over here? Q2n plus 1. I should have used different colors. What did I use for my other one? Used next state for my yellow. It's okay, whatever. You guys see what's going on? All right. What if I did the following for you? Beta. And put the following right there. How many states do I have? Still 2. Okay? Any questions about this? Yes?
When you say alpha and beta,
They're just numbers.
but like in terms of like an equation, when you're saying alpha and beta, and then you can also add like a second beta or alpha.
I'm just putting numbers in there.
But what does it look like in an equation? Like, if we're like taking pieces and putting them into the alpha, and like I want to make essentially like a diagram for myself to like.
So we're going to work from the diagram. He's going to give you a random hybrid, okay? So we're going to work this. So what's y of n equal to? Actually, you know what? Let's solve for this. We got to solve for next states, current inputs, current outputs. We're trying to solve for current input next states, correct? So let me see. I have 2 states, correct? So let me just write this over here. Q1n plus 1, right? What's that equal to? I got this input right there, right? X of n, correct? And then what's this right here? Plus beta of the output, y of n. But do you see a problem right here? The next state is a function of the output. That's not what we want. So let's solve for the output right now. What's the output equal to? Q2n. Cool. And then let me just write my arrows just to make it a little easier. You guys like the arrows? And that's it, right? You guys see what's going on? So now that we have this right here, right? Boom, you're done. Cool. Now we can replace this right here. X of n plus b q2 of n. Are we done? Yeah, that's it. Boom. Next state for Q1 done. All right. What about Q2? N plus 1. Here's Q2 right here, right? It's going to equal Q1 of n, correct? That's a current state, right? Plus this alpha term. And you see how it's multiplied by this output? But we already solved for that, right? Ain't that cool? Boom. All right, so now let's do our A's, B's, C's, and D's. Okay? Page 2. Keep this picture, okay? Keep this picture. You're going to be doing, so put it on, when you're on your exam, make sure it's legible. You can see it be like bang, bang, bang. Maybe even box your answers like this, the way. Okay, let me just do one more final thing. I'm going to write the word next state. Right, next. This is current output. Cur output. And this is next. Right? Those are the things we're trying to solve for, correct? And they are functions of cur inputs, right? And cur states. Right? Boom, 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 boom. Everyone's seen the pattern, okay? This is what you're going to be doing for tomorrow, not tomorrow. When's your guys' exam?
Tuesday.
Next Tuesday. It's going to be fast, okay? This doesn't look like anything you guys attacked this semester, correct? Or maybe in the homework assignments, right? It's going to do it for you, okay? But I'm going to try and tell you, I think the way Dr. Morris has been teaching it has probably been one of the best things I've seen. Like, Dr. Stewart, he didn't do it like this. I think we're going to go over, I think Dr. Morris went over memo, multiple input, multiple outputs. I think it's super, super cool what Dr. Morris is teaching you guys, but it's hard. I'll tell you that. You gotta practice, okay? You can't learn this overnight. All right. Anyways, don't want to waste time. Because we did start a little early. Not early. Anyways, I have the senior design dinner tonight, so I want to make sure I can make it to that one because I'm their senior design instructor. A. So, do I know how to do this? Let me just do it like this. Q1, n plus 1, and it's okay to be a visual learner, okay? I'm here too. N plus 1, and it's okay to do this, okay? It's okay to do this, all right? Do whatever is comfortable for you. I like doing this. Give myself a big square. That's my A. If you do this on the exam, you're fine. Hopefully. 1, n, Q2, n. And then plus, what do you call it? I'll just give some room. X of n. Okay? This is my B. So, here's our next state equation right here, right? It's equal to x of n, right? Just the 1, right? So, getting out the markers. That's for Q1. So Q1's on the top, so bang. Everyone see how I did that? And it's also equal to this beta term right here and Q2 right there, right? So we're going to get this Q2 right here, right? So it's going to be, let me think, right here, right? Right? Easy? And then that's it. There's nothing else, okay? Boom, equation done. Here's Q2. it's equal to Q1, right? So here's Q2, Q1, bang, it's going to be 1 right there. And then here's this alpha term, okay? Boom, easy. Is there any inputs? No. You got your A's and B's. Easy. And then you can punch this in MATLAB. You seeing that what's going on? What do you call it? Now let's do the other one. Let's do your C's and D's. Y of n. And it's basically a 1 by 1, so don't worry too hard. There's 2 states, so I'm going to give this big rectangle right here. Q1 of n, Q2 of n, plus D. And then if you want to, you can just draw a space right there. Here's your C. Our output is only equal to Q2. Easy. So I'm going to put a 1 right there. Color coding. 1, 0. There's no inputs. Boom. Oh, wait. D. X of n. There you go. And this is your D term. Punch this in MATLAB. You can do this. It's pretty fun. I really like it because all the way the next states work. Think of it like CP100, CP200. Remember those finite state machines? You're going tick, 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 right? You see how the signals and systems are going back to another major or to your actual big building classes? Yes?
Are you like taking essentially this and then like kind of flipping it over and then you get the 0 on 1 and then 0?
What do you mean?
You're like taking the C, which is 0, 1 vertical, which is column 0, 1 into, I guess into a horizontal. But it's like you're taking the array of like a 2 by 2 into a
1 by 2 and 2 by 1. The resulting matrix is a 1 by 1.
Yeah, so you're like taking the 2 by 2 into a 2 by 1 or a 1 by 2.
This 2 by 2?
Yeah.
Yeah, because we have 2 states, right? We have 2 next states. We have 2 equations we're trying to solve for, right? A 2 by 1, right? Right? So that means okay. And we have this right here is a 2 by 1, right? But we have these 2 states right here, correct? So it's going to be a 2 by 2. With 2 by 2 and 2 by 1 gives you 2 by 1. Right? Easy?
So you're just taking out the delay and then you just get...
No, I'm not dealing with delays. You're partially right. Basically, do you see these memory cells right here? Okay? Every time we have a memory cell, we're going to have a state. Okay? Does that make sense?
Yes.
So however many delays I have there is how many states I'm going to have. Okay? Does that make sense?
Yes. So when you're saying you have 2, so you're saying for sure you would have 2 states?
Yeah, because
Having 2 delays.
how many delays do I have?
2.
2. So that means I'm going to have 2 memory things. Or there's going to be 2 current states or two memory cells, right? There's going to be states in each cell, right? And I have 2 memory cells. That means I'm going to have 2 state equations.
What if you take out the beta?
Then, well, take out the beta, and then how would I replace that? Gain of 1, a gain of 0?
I think so, right?
Hey, if beta is equal to 0, it's just 0. That's it, right? Or actually, look at this right here. See, this just goes away. Or if it's 1, or if it's infinity, it's a random number. Does that make sense?
Yes, I'm just trying to figure out the relationship between the delays and the inputs.
Delay in the inputs? There is no. Well, there. Like, as in, like, solving for this? It's just looking at the graph.
Like, what's the delay in the equation?
The states?
Yes, n plus 1 is you had a delay to it, right?
This is the next state before it goes through the delay. So there's water here, right? I don't know. This right here is like, I don't know, something like a voltage spike, right? And now this is the delay. It's just gonna be, this is a 1 right here. I put a 1 right there, right? There's a 1 and zeros. And then here's a 0, right? If I go the next clock, clock cycles, right? It's 1 right here. Here's the change right there. The next state, remember those clock generators? You put a D flip-flops, right? clock the next thing. So now, boom, the 1 goes over here now, okay? It travels. And then the next state is whatever this and this spit out. What's the next state here?
So the delay is just like your -1.
Delay?
Because you're going from 1 to 0. Isn't it?
Wait, what?
Taking n plus 1 and going just to q.
N plus 1, yeah, and I get delayed, yeah. There's a delay in here. Okay. I don't want to spend time on this. I really don't. This should have been something we attacked it from the beginning or weeks ago. I don't know. But this is good information to know. Signals and systems. You guys remember this? I'm getting afraid right now, okay? When I delay, what do you call it? Delay, what do you call it? It does, I don't know, z minus 1 or z minus 1. What's another way of calling it a delay? N is equal to 1 or something like that. Let me remember. If my system looked like this, t, what do you call it? N transforms to n minus 1 or something like that. I don't know how to explain it. Point is, if I have a delay, what's going to happen to the input? It's just going to go n minus 1. That's it. All right? There's a delay. Does that make sense? The signals and systems. When did we learn this? 1.
So we're just adding the 1 first and then having it stop instead of having like n minus 1.
I delay it 3 times.
N minus 3.
Yeah. How many states do I have here? 3. Because then if Dr. Morris... Oh, this is actually a good lesson. If Dr. Morris did the following. And yeah. You can do this, right? There's 3 no, I put another delay there, right? 4 states. 4 next states. 4 by 4. Do you see what's going on? Is that making sense?
So now you just, I mean, given what I saw from, I mean, the plus is right there, right?
Yeah, I put a plus, and then everything goes this way, this way, this way, this way, this way, this way. This is a node. Boom, boom. Are you seeing what's going on?
So would you start with n plus 1 with c as well? Or would you go to n minus 1 first?
Well, funny enough, this wouldn't be x minus 3. Now this would be y of n, right? But what's my next state? Okay, I'm going to use a different marker. This is a good knowledge, good thing to know. Where did I put my markers? Right here. Pull out my trusty good guy green marker. Okay, so how do we set up our states? Let me just do this right here. Q1, N right there. Q2 is right there, right? And Q3 is right here, right? Everyone, and then Q4 of N is, oh, not there. It's right here. Everyone seeing what's going on? And then let me grab another marker. Let's see, a painful marker. Should I use, I thought I had my red one. Magenta. Let's use magenta. So now do your next states, okay? Q1N right here, right? What's the next state for this guy? It's going to be Q1N plus 1 over here, right? And then Q2N plus 1 is over here, right? And then Q3N plus 1 is right there, right? Everyone's seeing, and then right here, Q4N plus 1 is right there. Ain't that cool? So now you guys enter the control theory. You guys see all those funny block diagrams? You see the controls like, oh, all these feedback paths and it's like a snake. It looks crazy. But once you start attacking from this, problems don't look that scary after all, right? Sounds cool? Is this making sense? And then you can get your state spaces.
So then would you go, like, when you're ordering the equations, would you go with the first yn, then alpha, then bravo, then Charlie?
It just depends on how you want to set it up. Okay, we love to be unique, right? It's okay. So I'm going to do the following. Q 4 n plus 1, Q2 n plus 2, or 1, Q1 n plus 1, Q3 n plus 1. Q4, 2, 1, 3. You guys see my OCPD? And then plus whatever else, okay? You see what's going on? Do you see how I'm doing 4, 2, 1, 3, right? As long as I'm consistent, okay? And then same thing. Oh yeah, you see this right here? I'm gonna call it fat Q double bar, I don't know, of n. You see this right here? You see this funny symbol? I made a hat. It's got a little hat. You like the hat? Cool. When you're solving for your y of n, you're going to have a C, Q, hat. Make sure this is the same as this. Okay? Are you seeing what's going on? So in fact, it would be, well, plus dx of n. Make sure C, Q4, Q2, Q1, Q3. Make sure this is the same. If these aren't the same, you're going to get different outputs because that's how state space equations work. So this equation and this equation are tied by one thing, and that's this big current state. Okay? Finite state machine, CP 100, CP 200. Cool? And no, this is a good lesson. Don't worry. Don't think everyone's like, hey, what the heck? We're focusing on this. Based on what I'm seeing, yeah, you guys are going to get some pretty painful block diagrams. I'll tell you that. So this is a good lesson. Okay? Yes?
Why is the order of the Q4 to Q3 the way it is? Is that like intentional or is it?
This? I'm being special.
Is it just special? Like,
I'm just being special.
but you could just make it numerical, or
What did Dr. Morris say in class? I really don't want to waste time on this now, okay? I started 1, 2, 3, 4, right? I could have done 1, 2, 3, 4, correct? Or I could have done A, B, C, D, or I don't know, any pattern. As long as you're consistent, it doesn't matter. V equals IR. If you're going up the waterfall or going up an elevator, going down the hill, whatever you want. It's whatever is comfortable for you. At that point, you got to practice. Okay?
so
It's just your style.
choice?
Yeah, it's just your style. But you got to be consistent because MATLAB's going to be running this. Okay? Whatever makes it work, and don't worry, it's easy to tell what's going on because there is one equation that ties it. The A and the C's are also directly linked by, well, this Q right here. It's really easy to tell what you did. Anyways, any questions about that? Okay? We only have 25 minutes. I don't want to waste more time on this. We still have 6 more problems to go. See if I can cheese this in 1 minute. So, the other thing you guys are going to talk about on the exam, because I really don't want to waste time. Let's see. I'm going to have to start throwing this at you. Let me see. You guys know how to find transfer functions, correct? Analog and digital. Let's see. I'm trying to think about it. Anyways, I'm just gonna write it. Minus plus a1 yn minus 1 plus a2 yn minus 2 is equal to what do you call it? Second order. I don't know. Oh, yeah, whatever. X of n plus b1 x of n minus 1 plus b2 x n minus 2, correct? If this is the digital system, correct, how do you find a transfer function? Yeah, you just do the z minus 1s, correct? Or the yz's, right? Is that cool? And then well, funny enough, no, this is bad. Y n minus n transforms into z to the minus n y of z. Cool? Everyone seen that pattern? So what's this transfer function? I'm gonna shorthand it, okay? Yz, and I'm gonna do 1 plus a1 z minus 1 plus a2 z minus 2, right? Is equal to x z 1 plus z b1 z minus 1 plus b2 z minus 2, right? Easy. What's h of z equal to? Output over input, because that's what matters. So here's my output, or here's my poles. Don't forget your poles, okay? Right? And here's your zeros, right? So then it's going to be 1 plus b1z minus 1 plus b2z minus 2 over 1 plus a1z minus 1 plus a2z minus 2. I should have done that. Are there any questions about that? Okay, but there's another way to rewrite this, okay? You could do the following, where I'm going to shorthand this really hard, but y'all better understand what to do. C squared over z squared, right? So you can make some really nice numbers out here, correct? So it's all easier to understand. That's what makes sense to me, okay? But this right here is the true answer, but if you want to make it shorthanded, z squared plus b1z plus b2 over z squared plus a1z plus a2. Boom, right? What's this equal to? We have a second order on the top, and we have a second order on the bottom, right? What does that mean? I'm going to have 2 zeros and 2 poles, correct? So that means you're going to do this for me. You're going to study this on your own. Let me see. Z plus z or 0, 1. That's a bad way to do it. Anyway, what should I use? Not z, because we already used z. Because this one, I was going to do the bottom right here. Z plus P1, Z plus P2, right? P for pole, right? And then what should I use for here? I don't know. Let me see. X1, okay, whatever. Or not X1, I don't know. 0. Z plus 0, 2, I don't know. But you see what I'm trying to do, right? Because long story short, what you're going to do on your exam, page 5, this is terrible, I don't like this. Let me see. HZ, let me see, Z plus, I'm gonna call it A, alpha, Z plus beta, Z plus P1, Z plus P2, okay? Draw the region of convergence. First, draw your unit circle right there, right? And you're going to solve for these zeros and poles, okay? So, I don't know. In the end, let's see. You guys want to make a stable system, causal system? Stable and causal, or a stable or a mix of two? What do you want? What do you want to do?
Whatever's on the exam.
And I won't give what's on the exam.
I'm gonna guess causal
let's see, put a pole right here, and then I'm going to put a 0 over here, and I'll put a 0 over here. Give the ROC if the described system is stable. Is it stable? Well, is it causal? Actually, tell me, is this stable or is this causal? This is not stable, right? Or wrong? Well, you see our pole right here, right? See right there, if I try to draw my region convergence, it's not going to have, this pole is in that region of convergence. It can't exist. So if I did like this, right, my ROC is that way. It'll be a causal system, but it's not stable. Okay? How do I make it stable then? If I draw it like this right here, and draw right here, if I did it like this, right? Now it's stable. Stable, not causal. Right? Easy? I think I gave you guys the answer. Anyways. What if he gives you the following? I'm going to write these dream poles over here. Dream pole, bang and bang. P alpha, P alpha star. Right? What does this mean? Conjugate pairs? Right? So that means that makes your job easy. So now you can just do it like this. And then if you wanted to make it stable and causal, it'll work now. So what happens if you have an imaginary number? Yep, that's what's going to happen. Okay? He could throw you an imaginary number. Or as in basically what's that quadratic equation? Yeah, you're going to get like real plus imaginary, okay? And a complex conjugate. Okay? Everyone can do that. And that makes your job so much easier because now the poles are one thing or the other. Okay? Any questions? Page 5, or no, page 6. Page 7. Yay. So let me see. Can you do an analog version of that? Easy. Can you get the state space equations for the analog cases? So if I did the following again, yeah, let me make it tough. Should I make it tough? Okay. I'm gonna shorthand this really crazy. A1. Is that how I want to do it? Plus y. A2 is equal to x plus b1 x plus b2. Right? Is that cool? Differential equations. That's how we solve for a lot of our convolutions and everything we did from the previous exams and classes, correct? That's how the world works because we want to know what's happening next, correct? But differentiators are hard to build. They're hard to keep stable because you have the infinite case where, you guys know what a differentiator is? Right? It's a differentiator, okay? Because something immediately happens here, the voltage is going to go spiking through that, resistor, correct? And then slow signals, yeah, they don't do much, okay? Anyways, AC passes through the capacitor. 320? You guys missed that class? You missed my lab. Yeah, that was a good lab. Anyways, they're hard They're hard to build. They're really hard. So instead, we just build these things called minus plus. So this right here is a differentiator, right? This right here is an integrator. Okay? This is a lot easier to build. They're really, really nice. They're pretty chill, but they can blow up, but slowly blow up. Because you see this capacitor needs time to charge. So it'll either go to infinity or go to not, like plus infinity or minus infinity. But it won't blow up like this. This one just spikes. Like if there's a spike here, this spike just goes here and ruins your output. So, well, it destroys this part here too. But they're funny. Anyways, why was I bringing that up? There's a way to break this circuit so it's easier for you. You see this double integral sign? Did he show you how to do this? Did he show you how to do analog stuff?
Yeah, but in a different way.
How did he do it?
We just turn it into the Laplace equivalent, and we're probably going to go s squared by s at the beginning, and then we divide by s squared on both sides. That way we get like s to the negative 1. And then it's like s to the negative k. That's how many integrators there are.
Oh.
And then we do our direct form.
Oh gosh, I would love to know how he did that. Anyways, this is how Dr. Stevie taught me, and this is how I would probably show you guys. And funny enough, yeah, you're absolutely correct. You're absolutely correct. You're not wrong, and I don't think he's expecting you to go from what I'm doing to... I think I'm going a little extra here, but it's good to know this, okay? You have the differentials, correct? When I do a double integral of this output, right? The second order, second differential of the output, right? What happens? Just it cancels, turns to the y. Plus a1y, what do you call it? Integral y, right? Plus a2 double integral y, right there, right? Is equal to x plus b1 integral of x plus b2 double integral of x, right there, right? You guys see what I'm trying to do? Now you have an output, now you have an input, and all you can do, and I'll do this in the next page, because this is actually what he's expecting you to do, not this, but he's going to give you the Laplace transform, okay? Right? So from the Laplace transform, draw the block diagram. So, but this is the way Stubru taught me, okay? So tell me if I'm wrong, tell me if I'm wrong, right, wrong, whatever you want. So remember this equation right there? And he says to do a direct form to canonical block diagram. Okay? He doesn't say that. He says canonical. You guys know what canonical is? Direct form 2. What does MATLAB use? Canonical form. Direct form 2. So when you guys turn in your final assignment, what's MATLAB using? Not direct form 1. Using direct form 2. Canonical. All right? Output, input. Okay? What are you going to do? Do this on your exam. X, and then direct form 2, the water goes up, no, goes backwards. So let me see, plus, and then water goes, water goes forward. Just put a block there, you never know. Then, I'm thinking Y. There we go, plus, okay, here's my y of t, here's my x of t, but let me see. Should I write this a different way because this is a little confusing for me? So if I make y equal to, what do you call it, x plus b1 x plus b2 double x right there, right? This is just for me to watch. Minus a1 y minus a2 double integral y. Okay? So what does the output C? C is minus a1, correct? And it's got one integral, right? So here's my y, right? And now I want to do my integrals. Remember how the block diagrams worked? Where we have something in the middle right here, something in the middle over here, correct? Integral 1, integral 2, correct? I want one integral for my output, right? So this right here, okay, remember, here's my direct form 2, right? Remember direct form 2? It's the feedbacks right here, feed forwards over here. Everyone understand what I'm trying to do? So I'm going to put a block right there, okay? Minus A1, correct? And this is going to go backwards. And then goes backwards. This goes forward. I'm going to put a block over there, plus. And I'll put a block over here. You never know. And then the way water goes, it goes like this. Boom. Everyone seeing how I'm trying to draw this, okay? Yes? And then I'll do something with this one. The output, right? Here's my output. And here's that first integral, correct? Right? Let me see if I can show you what I'm trying to do. Here's my output. Give me a second, give me a second. Ba-ba-bum. This is A0, this is B. I'm trying to think. Ignore this one, this is just the wire. A1, A2. What I'm trying to show you guys is if I were to put a state here, just give me a second. I'm crashing out. Hold up. One integral right here, right? A1, boom, it goes like that, right? That's what I'm trying to show you. You guys see that? It might be easier for the input, okay? Let's do the input. See this B1 and this one first integral, correct? Let me grab the yellow marker. Here's my input, right? I'm gonna follow this waterfall. First integral, correct? And it has to go through B1, right? Everyone see what I'm trying to do? The output sees that, right? Does that make sense? Yes? Here's B2, double integral x, correct? Same thing, I get double integral right there, right? Boom. And then that B2 is seen by the output, okay? Second order is a little funny because it's harder to see the outputs, but it's more of a trust me, bro, than anything else, okay? So same thing for the output. You see how the output's kind of, see this wire right there? This whole thing is an output if you think about it, right? Correct? So this output right here, right, goes through here, boom. Does that make sense? And then here's the other output, double integral, boom. That's your block diagram, okay?
Can I show you how it's done?
Yeah, show me how he did it. I want to see if I'm on the right track.
This is like horizontally instead of like vertically like that,
Okay.
which is might be a little more clear. But like the input is right here. That
Yeah.
way now it goes through two integrators, and then your output is right here, and it feeds back.
Oh,
Yeah.
I know what he's doing.
Yeah.
Okay. Yeah, funny enough, that's the controls way. That's a cool one.
Okay.
Okay? But anyways,
Same.
let me show you. Would it be funny if I did it like this, right? And I'm going to write with a different marker, orange. This is all a water node, right? Right? This is all my water, correct? If I were to call this one right here x of n right here, right? This whole node, right? Everyone see what's going on? You see this output right here? Everything's kind of feeding into one side. If I made this all, let me see, how did he do it again? Y of t right there, right? You see that? See this water right here? Let me see. I hope this makes sense. Does that make sense a little better? And then it's kind of going that way. Well, the x is on the bottom, the y is on the top, right? Just flip it upside down. Is this making sense? I'm losing people.
I think it just needs to be cleaner.
Huh?
I think it just needs to be a little cleaner, and it's a little confusing.
Yeah, so that, because I'm showing you the Dr. Stuber way, but this is how you would attack that problem. But anyways, this is page 7. No, this is page 8. Right? Page 8. I really don't want to go too crazy on these. Long story short, if I were to show you this, I'll give you guys a goodie to go home with. Did we miss any?
Do you have anything after this?
Huh?
Do you have to leave that?
Yeah, I do. But I still have a few more minutes. Don't worry. I can go over a few more things. Let's see. Remember that block diagram I talked about earlier? That funky whatever? What's his name? X of t, right? Plus. And let me see. I'm going to do the following. Or no. How did he do it again? Integral like that, right? And then let me see. Was there anything on the top? It was just a wire, right?
That's if you're going, if you're going to different states using like a magnitude, whatever
Okay.
you want.
And then he would go down like this right here, right?
Yeah.
Okay. And then because it's going forward, right? Feed forward back. Okay. And then the waterfall is going like that, correct?
Yeah, you can go down to the first integrator. You need to, I don't know,
Like that.
differential, yeah, you can to the right.
If I call this one B1,
Yeah.
correct? So now what if he did the following? And this is actually okay. What if you did that? This is what I was trying to lead with this. Okay, I like copy paste. Okay, I like copy pasting. You see this block diagram is the same thing we've been doing from day one. Well, Subaru way. See how I'm trying to show you guys right there? Because the next conversation is generate the state space equations for this. How do we do that? So remember how I showed you like Q1 right there, right? Q2 right there, right? And then if the water's going like this way, right? Q3, right? Going backwards, I'm going to get, use the green marker, Q3 next state, right? And then right here is going to be Q2 next state. And this right here is going to be Q1 next state. That's what I was trying to lead with this conversation right here. Okay? On the exam. And how do we solve for the A's, B's, C's, and D's, right? Same thing we did with the digital equation, okay? But he's going to give you a second order equation, so I hope you guys are ready with that. Anyways, let me see. And everyone can do heavy side, correct? Heavy side equation. Go from, find the residues in the poles, correct? Residues and poles. So if I were to tell you, what's his name? H of S, or S right here, it's going to get, what do you call it? A, S plus P1 plus B, S plus P2, right? What's this right here? Residue. What's this right here? Pole. Making sense? And then there's an equivalent for H of Z, right? Where it's going to be A e to the P1 plus B e to the P2. Oh, don't forget the T ends. Okay? Or no. Skipping a step. A, was it? I'm blanking out again. 1 plus P1Z minus 1, right? Plus B1 plus P2Z minus 2, or minus 1 right there, right? Everyone can get these equations, correct? And then how do you, okay, if I give you an input, everyone can go from this to U of S is equal to 1 over S, right? And multiply this to get more poles and zeros. That's going to be on the exam. Oh, yeah. And what? Let's say worst case scenario times, make it really hard on you guys. Amplitude e to the, what do you call it, alpha t. And how do you get the Laplace transform of that? Right? Are you guys seeing what's going on? Just multiply this to that and you're done. Easy? Any questions about that? And oh yeah, impulse response, right? You just throw a delta into it. Easy. And then everyone can do multiple input, multiple outputs. He's going to ask you to find that big matrix. So A, B, C, D, right? So now instead of, what's his name? Here's page 9. Oh, I'm going through a lot of pages tonight. He really loves this. Can you do this for a analog and digital system? Where, what do you call it? Remember that big Q? I don't know, double hat, whatever. Remember that is equal to A, or no, this is next state. This is next state. Right? So what happens if your output Y1, Y2, Y of, I don't know, N? What happens if you have multiple outputs? You're going to have multiple states, right? Or multiple inputs as well, okay? Inputs, kind of. So let's just say you have two states, right? Two states. Q1, Q2, right? So this right here, let's just do Y3, okay? It's a 3 by 1. Wait, no. Yeah, 3 rows, one column, correct? And I have a 2 by 1 right there. Q1, Q2, right? What does that mean for this matrix right here? The C right here. What's it going to have to be if I have 3 inputs, right, or 3 outputs, but 2 states? 3 by 2, and then the resulting equation is a 3 by 1. Good job, y'all. See? And then let's say, what if I did the following? Yeah, sure. 1 input, right? I have a 1 by 1, but my thing is 3 by 1. And how do I satisfy, so this resulting right here is 3x1 right here, right? This resulting thing right there, right? How do you add 2 matrices? You got to make sure it's a 3 by 1 and a 3 by 1, right? So this has to be a 3 by 1. All right? So 1, 2, 2, 3. Right? Make sense?
Would you just repeat the same value for the 1 by 1 3 times all the way up and down?
1 by 1. Which one?
Was it 1 by 1?
This one right here? This the x input? X of t?
Yeah.
Yeah, just one input. So we have a single input, multiple output. You guys know how that works? So think about like if I have one input, right? So MATLAB, right? You have one cosine. But let's just say you wanted to cheese your homework and you build direct form 1, direct form 2, direct form 3, or whatever. And you have 3 different outputs, but one little input. So easy, lazy way. But what if he does, I don't know, W, T or something like that. So now it's a 2 by 1, right? This ain't gonna work. Right? Not gonna work. So that means it's gotta be 3 by 2. 2 inputs, right? So that means I have a cosine wave, I have a sine wave, and they're just doing their own things. Right? Does that change right here? No. Well, depending on how many outputs you have, okay? Any questions about this? And then basically, these inputs are affecting the outputs, correct? How do I find the transfer function of, let's just say, I don't know, y3 over wt? Well, you just plug and chug the equations, okay? Not that hard. Any questions about that? And then find the impulse response. So basically when this reacts, what's the output with respect to an impulse response at WT or whatever the input is? Right? This is really cool. I think the biggest tip I can give you guys is the Shams outline. There's a lot of problems. I think the website version, super amazing. If you're not getting these problems, it takes practice. You're gonna have to practice problems every day. Back when I was an undergrad, it took me a while to understand the beauty of signals and systems. Yes?
Sorry, so website version of Shams outline on
It's just to show everyone again. You didn't watch my last video, correct? Let me see. It's right. Where did he put it? Here's the book right here. But you need to have your ACE account to log it to get the book for free. Okay? Generates so many problems. It's amazing. You can find some multiple input, multiple outputs. You see all these weird, wonky equations right here? Look at this wonky system. Guess what's going to be on the exam? Maybe this wonky system. But can you do it? It's the same methodology. Remember this? Q1, Q2, Q3? This block diagram is not going to be like that. But something wonky is going to be on the exam. I promise you that. So it's going to basically stretch your mind. Yes?
Was there like any like really tricky?
This? That's a tricky problem. I'm giving you guys the answers.
What chapters do we like focus on?
I actually don't know the Shams one, but let me see. I do have, okay, you know what? Because I actually have the book on me. It's a really nice book to have. Let's see. If I were to give you guys homework, this is how Dr. Stuber does his grading, by the way. Signals and systems. I would do this. This is good. Yeah, study that. Ooh, this one's, all this is good. But what do you need for your exam? Ooh, I think if you do chapter 7, let's go to chapter 7. Let's see. Chapter 7. Do I have multiple input? Look at these wonky systems. There's so much homework. And look, you see Q2? Oh, let me see. Q2 right here, right? Of n. Q2 n plus 1, right? It's all the stuff we've been showing y'all, okay? Oh, look at this. Ooh, you guys want to do that? Try that for homework. Ooh, this one's cute. This right here, first order. Anyways, there's a lot of problems in here, and I think, not gonna lie, I think the way Dr. Morris taught it is probably one of the craziest, amazing thing I've ever seen. Oh yeah, stuff like this. This is good. Yeah, look at this multiple. Well, it's the same input, single input, different outputs, or well, one output. Let me see. Is there any other good problems in here? If you want, you can create your own nth order. Let me see. Continuous time. Because I don't know any good problems to throw at you because I don't know anything from the book that I've read. Let me see. If you guys find a problem, throw it at your friends. Supplementary problems. There's no hard ones in here. Maybe because they don't expect y'all to try multiple inputs. But I guess Dr. Morris is, so that will be your challenge problem. Let me just read the rest of this. Oh yeah, convolution. Can you do convolution of two signals? And that's it. So basically, he's trying to test you on your exam 1. It could be the first, it could be the same problem. Please. And he does go over the exam, right? Did he go over exam 1?
No, he's going to go over his final.
But did he go over the exam solutions from exam 1?
He did in office hours, but he didn't go through all of it.
I would highly suggest, please, talking to him. Go to his office hours, okay? If you want to be successful in this class, well, I'm not saying if. Suggested is to go to the office hours, visit him, say hello. And then I can try to be a source, but I have other things going on like the labs. But else, that's my study session right there. Let me see if there's any last trick questions. Yeah, literally this exam. Yeah, it's just solving for A's, B's, C's, D's. Oh yeah, zero input response. Zero state response. Exam 2. Any questions? Have a good day, everybody. It was a pleasure being your MATLAB instructor.